Hello everyone, welcome back to this YouTube channel, IBwontcrushyou, and today we're dealing with vectors, and this topic is dedicated only for HL, higher level, and as always we'll go through some problems to make sure that you are familiar with this topic. So let's get started. Problem 1. A vector in the plane is defined as v equals minus 3, 4. A. Find the magnitude of v. So here we have to use our formula for the magnitude of the vector, and it looks like this. And now we can substitute these values, so absolute value of v, and we have two values, minus 3 and 4, so we have to substitute only these two, so negative 3 squared plus 4 squared, so of course this is 9 plus 16, so square root of 25, so it's just 5. B. Determine the unit vector in the same direction as v. So let's denote our new vector as w equals. And if we have to determine the unit vector in the same direction, so we take 1 over our magnitude, and then we multiply with our vector from the command, so vector v, so minus 3 and 4, so this is 1 over 5 multiplied by our vector, so our final answer is negative 3 over 5 and 4 over 5, and that's our vector. C. State the angle between v and the positive x-axis. Give your answer in degrees. So in this case, and in the case of the same problems, we have to use tangent, maybe alpha, and we know from our trigonometric rules that tangent of some angle is opposite over adjacent, so TOA. I hope that you remember. So TOA, so tangent alpha equals opposite over adjacent, and in our case, opposite is 4 and adjacent is negative 3, because this is our x and this is our y. So now we can calculate our angle, so we can simply find it in solver on our GDC, or by dividing both sides by tangent, so in other words multiplying both sides with tangent to the power of minus 1, so alpha equals, and we have to calculate it. So our alpha is negative 53.13 degrees. However, we have to spot that x, so minus 3, is less than 0, and y, 4, is greater than 0. So our vector lies in the second quadrant. That's why our angle cannot be negative, so we have to add 180 degrees. So 180 degrees plus our angle that we calculated, so this is 126.9 degrees. Problem 2. Let A 2 minus 1 and B 7 3 be points in the plane A. Find the vector AB. So here simply we have to subtract from our second letter, so from B we subtract our first letter, so A, and it equals, and we have to just subtract the values. So here we have 7 and 3, coordinates of B, and we subtract coordinates of A. So here 2 and here -1. And from this we have 5, and here we have 3 minus -1, so 3 plus 1, so just 4. B. Determine the equation of the line through A and B using vector form. So firstly, let's write down the general form of a line in vector notation. So we can take, for example, R, vector R equals vector A plus T and times vector D. So A is our point on the line, so the position vector. D is our direction vector, and T is just a parameter. So in our case, we have 2 points, so we can either choose A or B, it doesn't matter. Let's choose A because it's our first letter, so this is our vector A. So R equals 2 and -1 plus T, and here we have our direction vector, and our direction vector is this, not just B, but our direction vector, so 5 and 4. And that's our equation. And C, point C, K5 lies on this line, find K. So, because our point C lies on this line that we already found, we can substitute this point as our vector. So, K and 5 equals 2, -1 plus T and 5, 4. So now we have to make some equations. The first one is K equals 2 plus 5 times T, and the second one is 5 equals -1 plus 4T. So in the first equation we have 2 unknowns, and in the second one we have just T. So we know that we can simply calculate it from a solver. However, we can also move our -1 from right hand side to left hand side. So we have 6 equals 4T, and here our equation stays the same. So from the second equation we can divide both sides by 4. So we know that 6 over 4 is T. So we can substitute it in here, times 6 over 4. Of course, we can shorten our value of T. So T is 3 over 2, and K is 9.5. Problem 3. 2 lines are given in vector form, and we have L1 and L2. And we have to show that the 2 lines are parallel and determine whether they are coincident or distinct. So in this type of question, firstly we have to identify the direction vectors. So for L1 we have direction vector that is 3 and -1, and for L2 we have second direction vector and this is -6 and 2. Now after identifying these direction vectors we have to check if their direction vectors are scalar multiplies of each other, and we can observe that our direction vector D1, so this from L1, when multiplied with -2 is the same as direction vector from the second line, because negative 2 times 3 is negative 6, and negative 2 times negative 1 is just 2. So it claims that they are parallel, and now we have to check whether they are coincident or distinct. So now we need to test if one line can be obtained from the other by shifting along the common direction. So firstly, let's take the position vectors of our points. So our first position vector, let's denote it as vector A1. So this is 1 and 2, and our second position vector is 4 and 7. Now let's compute the vector connecting them. So from the second vector, position vector, we subtract the first position vector. So we have 4, 7 minus 1, 2. So our vector is 3, 5. And now if our 3, 5, so our new vector were parallel to vector B1, the two lines will lie on top of each other. So we have to check if our vector 3, 5 equals, and let's take the letter S, and if is it equal to S times our D1 vector. So 3 minus 1, and we have to find scalar for S. So we have two equations, 3 equals S times 3, and 5 equals S times minus 1. So we know that from the first one we have 1, and from the second one we have negative 5. So we know that 1 is not equal to negative 5, and in this case they are not coincident, and they are just distinct parallel lines. Problem 4. Consider two vectors u and v, and in A we have to compute u times v. So all we have to do, firstly, we take our formula from the booklet, and the name of this formula is scalar product, and we take the first one, so v times w equals, and we have v1 times w1 plus v2 times w2 plus v3 times w3. So we can substitute our values. So this is our first value, so v1, and this is our also first value, so w1. So we just multiply these values. So 2 times negative 1 plus, then we have the second values, so plus 1 times 3, and the last values are negative 2 times 0. So from this we have negative 2 plus 3 plus 0, so this is equal to 1. B. Find the angle between u and v and in degrees. So you can take a look at the formulas from your booklet, and you can observe the formula that is called angle between two vectors. And it looks like this, and the numerator is just 1 because we already calculate the value of numerator, so it's just 1, and these values are just magnitudes of our vectors. So firstly we have vector u, so the magnitude is 2 squared plus 1 squared plus minus 2 squared, And for v, vector v, the magnitude is -1 squared plus 3 squared plus 0 squared. So we have to calculate these values on our GDC. So these are our magnitudes, and here we can leave a square root of 10 because that's our exact value, and that's not our final answer. So we have to substitute them into our equation, and then we can calculate. So here without equals, so cosine theta equals 1 over, and we have 3 square roots of 10. So now we can calculate theta either by typing it into solver or by multiplying both sides with cosine to the power of -1, and the answer, so our angle is 83.9 degrees. C. State whether the vectors are perpendicular, acute, or obtuse. So, because our theta is less than 90 degrees, so less than right angle, the angle, we know that the angle is acute, so not perpendicular. Problem 5. A triangle has vertices A, B, and C. A, find vectors AB and AC. So as previously, we have to subtract from the second letter the first one. So vector AB is just B minus A. So 3, 1, 4, minus, 1, 2, 0. And the same goes with AC. So C minus A equals, and we have 0, -1, 2, minus, 1, 2, 0. And now we have to calculate these values. So we have 2, -1, and 4. And in here we have -1, -3, and 2. B, calculate the angle at vertex A. So we have to use our formula for the angle between two vectors. So let's firstly calculate our numerator using scalar product. So vector AB times AC, of course, vector, equals. We have 2 times -1, so -2, plus -1 times -3, so just 3, and plus 4 times 2, 8. So from this we have just 9. So we have cosine theta equals, here we have 9, and now we have to calculate magnitudes of both vectors AB and AC. And these are our answers calculated from the formula for the magnitude of a vector. And it's better to leave them as exact values because that's not our final answer. Now we have to substitute them into denominator, so square root of 21 times square root of 14. And now we can find it in solver, our angle, or we can simplify it by multiplying it by cosine to the -1 power, and the angle theta is 58.3 degrees. C. Determine the area of triangle ABC. So now we have to, of course, use our formula booklet because in there we have formula for the area of a parallelogram. And we know that parallelogram has sides parallel to each other. So when we divide parallelogram into triangles, we have two triangles that are the same. So we can take just half of this formula. So V times W, and this, as you can observe in your formula booklet, is vector product, and it looks like this. And of course our first vector is AB and the second one is AC, so we can copy them below. So we have our vectors, and now it takes a lot of time, however we have to do it manually. So here is our first vector, so AB, so we take the second value from our vector AB, so -1 times W3, so times 2. Then we subtract, and of course everything in the brackets. We subtract V3, so 4 times W2, so -3. Then we have V3, so 4 times W1, so -1, and we subtract V1, so 2 times W3, so also 2. Then we have V1, so 2 times W2, -3, minus, and we have V2, so -1 times W1, so -1. And we have to calculate everything. So these are my calculations. You can check if your answer is the same. Our vector is 10, -8 and -7. And now, because here we have, let's say, straight vertical lines, we have to calculate magnitude of this vector. So once again, we have 10 squared plus -8 squared plus -7 squared, and this is a square root of 213. So now we can substitute everything into our area. So we have 1/2 times square root of 213, and our answer is 7.30 units squared. Problem 6. The line is given by L and we are given vector R. The plane is, and we are given this plane denoted as pi, and we have to find the coordinates of the point where L intersects pi, so our plane. So firstly, in this type of question, we have write down our parametric coordinates. So we know that the first coordinate from our line is this. So this is x. So x is -1 plus 2 times t. Y is the second value, so 4 plus -1 times t, and z is 2 plus 3t, so we can simplify this value. So y is 4 minus 1t, so it's just 4 minus t. And now we have to substitute these letters into our plane equation. So Firstly, x is minus 1 plus 2t plus 2, and y is 4 minus t minus z, and in bracket 2 plus 3t, and it equals 5. So we can type it into GDC, into solver. So t is just 0, and in order to find the coordinates we have to substitute our point t into our equation. So we have r equals, and vector minus 1, 4, 2 plus 0, and here times vector 2 minus 1, 3, and of course this is just 0, so our coordinates are minus 1, 4, and 2. And that was the last problem from this topic, vectors, from geometry and trigonometry. And if you found this video helpful and useful, you can share video to your friends, leave a thumbs up and subscribe to this channel, and see you in the next video. Bye!